2017, I ran MID, as you can see in the first slide. It's an NGO focused on the development of open data in the country. I'm happy to be here with you today. This is my first DSA and also my first time presenting a dataset related to machine learning. To some of you with whom I spoke the last few days, I have a very strong literary background, and I only studied data, started from 8 years ago. So I'll try my best to make my presentation understandable by all of you. So, as it was said, this project is a Lacuna-funded data collection project, and the main objective was to build a data set for you to develop a solar panel detection algorithm. And to do this, the whole data set itself comes from both the annotation of both satellite and drone images. So the first thing we did then is the online job was to collect as much as satellite image. So we browse Google Earth, we browse cities, and once we find solar panel equipment on roof or in open spaces, we stop, we capture the image, and we save it as one image. So as you can see, we had more than 2,000 satellite images. And for this first step, we only make the screen capture on big cities where Google Earth image were at its best qualities. And so generally it was a human eyes recognition. As I live in the capital, for example, I know where there is a solar panel. But although we know and we are sure about whether it is a solar boiler or a solar panel, we still did a field check of approximately 20% of the images we captured. So that's for the satellite images. And for field work, we use drone to collect images. The model was the DJI-3 Pro Enterprise, and we had more than 9,000 images. And again, each flight was not an automatic flight that you can parameter for the zone to map, to take a photo each per second, and then you make the selection after. Again, it was for the pilot to search by his eyes where we can find the solar panel, and then we take the photos. So sometimes, as you can see, as in the example, sometimes we have very detailed, the solar panels were very big, and sometimes you take, depending on the altitude, sometimes you want to take a general view of an hotel. That was the case in the middle. And sometimes you want to focus on the solar panel very closely. So, therefore, once we get the image, as I said in the objective, we wanted to develop an algorithm to detect the solar panel. Our dataset is available in an Excel format which has 3 sheets, each sheet representing 3 levels of annotation from level 1, 2, and 3. And the first level was just a general description. So if I take the example, so it's the same. If I take the example of this photo, we have 14 panels. If we count one by one, right? So we could have described 14 zones. However, so in the first sheet, we answer questions such as, what exists in this photo? Is there solar panel, solar boil, or both? And how many zones can we find in this photo? So for these photos, we decided that there will be 6 in the yellow one that I tried. So that's for the first level. In the second level, we described more about the 6 zones that we identified in the first level. So here, for example, the first zone has 3 panels, the second has also 3, the third has just 1, like it is the case for the 5th too. So that is how we we try to describe where exactly in the image we can find the solar panel. So how about the level 3? So once it is described that zone 1 has 3 panels, where exactly it is now, because the whole photo is like this. So where is the zone 1? And this is where the level 3 is important. We use the GIMS, an open source software, to delimit each zone, and we use the width and the height of the photo, the pixel as the longitude and the latitude of each point. Because, for example, if this is the panel, we took 1, 2, 3, 4 points, and we took the width and the weight of this in the pixel format as the longitude and the latitude of it is exactly the location of the panel then. So that's the level 3. So in total, just a conclusion of what I said. At the end, we got more than 22,000 polygons, which is the zone. And a zone is not necessarily just one panel. It can be 6, 7. It depends. So, and at the end, we got all this value, the total value within the three sheets. So how it is used now? The main objective is to develop the algorithm, but it also can be used for simple statistical use for government, because each time in this slide you can see the Google Earth screen capture. Each time we capture an image, we try to make one capture as a household. We try so we can know how many families. So it's like a center of interest for solar energy adoption. So, and this leads us to the use case. So it's in French, but I wanted to be faithful to the photo the person sent to me. They were able to calculate the adoption of solar energy in Madagascar with the database. I didn't present here, but I only presented here the main dataset that was funded by Lacuna Fund, but there is a second dataset, which is a physical description of solar panel available in the market. And in the second dataset, we really went to the market and we take the measurement of each panel and its power. And one point also, I didn't say that in the level 1, there was other parameters, such as the image zoom, altitude, and it's not exactly the same for drone image and satellite image. For satellite, we have only one altitude, for example, but for a screen capture in Google Image, we had the camera altitude and the mouse altitude. So, and before we screen capture the image, we first take the superficie area of the panel. So this is where the second data set, where we have the technical and physical parameter of each panel solar, they work together. So for this, they were able to calculate the solar energy adoption in Madagascar. But until today, I haven't yet received any returns, any email on how they use the dataset for developing the algorithm. In the next few weeks, on the 21 and 22 of June, there will be a data day organized in Madagascar, and they will use this the dataset during an hackathon. So I don't have the results yet. So where's the dataset? It's on our open data platform. You can download here. It's under CC BY license, and don't hesitate to contact me once you have used the data. Thank you.